In today's class, I am going to explain the introduction to robotics. Regarding the robotics, what is the introduction that I want to enlighten in the today's video. So the robotics is a branch of technology that deals with the design, construction, operation and programming of robots. So the robots are autonomous or semi-autonomous mechanical devices designed to perform tasks with precision and efficiency. So the concept of robots dates back to ancient times, but the modern era of the robotics began in the 20th century. So the key milestones include the development of industrial robots, the introduction of computer controlled robots, and advancement in artificial intelligence and machine learning. So the robotics plays a significant role in various industries and sectors. It improves the efficiency, accuracy, and safety in tasks that are repetitive, dangerous, or require high precision. So the robotics is a fascinating field that combines various disciplines such as computer science, mechanical engineering, and electrical engineering. So to design, build and program intelligent machines called robots, these robots are capable of performing the tasks autonomously with minimal human intervention. The primary goal of robotics is to create machines that can replicate or enhance human capabilities, making them versatile, efficient, and reliable. Robots can be designed to perform repetitive or dangerous tasks, handle heavy loads, or operate in environments that are hazardous for humans. They can also be programmed to execute complex operations with precision and accuracy. So, the robots can be found in various industries, including manufacturing, healthcare, agriculture, and space exploration, automobile, etc. So, the key components of robotics, the mechanical systems, sensors, actuators, control systems. So, these the key components. So, what is the mechanical systems? Let us discuss in detail about the mechanical systems involved in robotics. The physical structure and mechanism of robots, including joints, actuators, and end effectors. So, these systems are responsible for providing stability, mobility, and the ability to interact with the environment. So the structure of a robot defines its physical form and determines its capabilities. It includes the overall shape, size, and configuration of the robot. Robots can have various structures such as humanoid, wheeled, legged, or manipulator arms. Now let us see that the humanoid structure. So now we can see this humanoid structure. It looks like a human. It looks like a human, and it involves a lot of joints. Now let us see the line diagram of the humanoid. The line diagram of the humanoid. Each one here it's representing the joints. Each one here it is representing joints and links, and here it joints and links. Okay. Now we can see that for a specific humanoid structure, it's involving a lot of joints and links. And here it's mentioned joint and degree of freedom. So what do you mean by the degree of freedom? So at each joint, how many ways it can move, it allowed to move, that defines the degree of freedom. At particular joint, it allowed only one direction and it restricted in all other directions. That is known as a single degree of freedom. If that joint is allowing in two directions, then it's a 2 degree of freedom and remaining are arrested. So you may not, just briefly I tell degrees of freedom. If any body in a space, it's having the 6 degrees of freedom. So what are the 6 degrees of freedom? So there is 3 translatory motions and 3 rotary motions. That body is in a space, it's freely available. Same body you can brought into the plane, any plane. then it arrested 3 degrees of freedom. It's having only 3 degrees of freedom. What are those 3 degrees of freedom? It can move in one linear direction, another linear direction, and it can rotate about perpendicular axis to the plane. It's having 3 degrees of freedom. Now let us see that here each joint here you can see that joint and joint is mentioned and degrees of freedom, the corresponding degrees of freedom. So now this here it show that head. So that head is having 2 degrees of freedom. And shoulder, the shoulder is having, shoulder means this one, the shoulder is having the 2 degrees of freedom. And elbow, the elbow is it's having 1 degree of freedom. So that pelvis is having the 2 degrees of freedom, and hip is having 3 degrees of freedom, and knee is 1 degree of freedom, ankle 2 degree of freedom, toe is 1 degree of freedom. Total this 24 the degrees of freedom for the humanoid structure. So the entire humanoid structure it's having 24 degrees of freedom. Next, see the wheeled structure. Now you can see that this wheeled structure robot here, it's moving with the help of these 4 wheels. It's moving with the help of these 4 wheels. The 4 wheels are mounted on the 4 legs, and it's moving on with the help of these wheels, and each wheel is providing this motor, and the motor will controls and moves in the direction, forward direction, reverse direction. And this body, you can see that entire this body is housing, and here it is providing the end effectors and arm end effectors, and it may be used for any purpose. It may be used for spray painting, or it may be used for inspection purpose. Like several applications you can use this wheel structure. So wheel structure, it means that the entire robot will move on a wheels, that you can clearly observe here. The wheels are provided. Next, legged structures, like a humanoid, how the moving one place to another place with the help of the legged. So then it is called as a legged structure. Now you can see that these are the 2 legs, like a human being, how the 2 legs are there. Similarly, you can construct this legger, and here providing the knee, here providing the knee, this one joint, and here it is hip, another joint, and here several joints are involved. This is called as a legged structure. You can see that how the robots are involved for legged structures. It's more like a human being, it's moving. So, that's called legged structure robots. And you can see that here it is another one with the legged structure robot. Robotics manipulator arms. You can see that the robotic manipulator arms. Okay, now you can see this is the robotic end effector, this is the end effector, and this is the arm. Okay, that is mounted here. So now it's a robotics manipulator arm. So it may be the different purposes. You can see that it's having the complete rotation in 360 degrees. It's having the complete in vertical axis. It's rotating in 360 degrees clockwise and anti-clockwise. And this arm, this link can having the rotation about this axis. The about axis it will rotate. It will rotate like this in the clockwise and anti-clockwise. And also here about this joint, this link can also having the rotations. Okay, and about this axis, this link is having the rotation either in the clockwise or anti-clockwise. Okay, and also this entire this unit is having this rotation like this. Okay, and these are the acting as the arms that the end effector, these 4 fingers are moving and towards to close the object and release the object for the purpose of pick and place. Like different applications you can use the manipulator arms. So now what are the key components of robotics? What are the key components of robotics? Now let us see that the key components of robotics are that is mechanical systems. Next is sensors. So the sensors, what is the main purpose? The robot sensors play a crucial role in following the robots to perceive and interact with their environment. So these sensors gather information from the surroundings and provide input to the robot's control system. Here are some common types of robot sensors. That is the vision sensors, and you can see that the vision sensors, the cameras are used to just capture the images, and the depth sensors, LiDAR sensors, Okay, all these comes under the vision sensors, the cameras, depth sensors, lidar sensors. These are the comes under this. So the proximity sensors. So the proximity, that is a force or a torque sensors. It's having the proximity sensors and infrared sensors, ultrasonic sensors. So next, tactile sensors. So that is a capacitive sensors, pressure sensors. For the different purposes, we are using these sensors to sense and to send the signals to the control systems. Accordingly, the control systems will send the commands to operate or control the manipulator. So, environmental sensors, that is the temperature sensors and humidity. What is the humidity of that surrounding atmosphere, that also you can measure with the help of the humidity sensors and gas sensors. The motion and position sensors, so that is encoders, internal measurement units, IMU. So this all comes under the sensors. So what are the other types of sensors? That is global positioning system sensor, GPS. Nowadays that is also very important, where that part will be there globally, that in worldwide you can see that particular position with the help of the GPS system. That also you can measure. And biometric sensors. Nowadays you are using all the companies that introduce the biometric for thumb impressions. So next is the actuators. So what is the actuators? Robot actuators are essential components that enable robots to physically move, manipulate objects and perform various tasks. So actuators convert electrical, hydraulic and pneumatic energy into mechanical motions or force. So here are some common types of robot actuators. Electric motors, that is a DC motors and servo motors. Actuators are also pneumatic actuators. So that is a pneumatic cylinders and pneumatic rotary actuators. It's working with the help of the compressed air. The pneumatic devices are so the pneumatic cylinders is having the to and fro motion. Now it's having only the to and fro motion. It can move in this direction. Okay, it can move in this direction to and fro. Okay, now here you can see that pneumatic rotary actuators. So the rotary actuators, once this connected to this motor, or then it will rotating, and here also you see that these two are inlet and outlet of this air. So the pneumatic compressed air will send that, with the help of this air, this will be rotating. It will connect it to the prime mover. The prime mover accordingly it will rotate. So this hydraulic actuators. So hydraulic actuators also you can see that hydraulic cylinders. So the hydraulic cylinders, here we are give the input and here it is output. You have to supply the high pressure fluid through this, and that will rotate this shaft, and the shaft is connected to the prime mover. It will works. Similarly, this another example of the hydraulic actuators. So the control systems. So robot control systems are responsible for governing the behavior and the movement of robots. So these systems receive input from various sensors, process the information and generate commands to actuators to execute desired actions. Here are some key aspects of robot control systems, that is open loop control systems and closed loop control systems. So control systems are in the open loop control systems, you can see that the controller, this input, the required process response to the controller, and output of the controller that will fed to this process, and it will performing the process, then will get the desired output, the process output. Okay, here the process input will be there. So whatever this output will happening, it's not measured. Okay, there is no feedback. So you are giving some input to the system and will get the output of the system. So that type of systems or control systems are known as open loop control systems. This is called open loop control systems. Okay, now you can see that another type here, we are giving the input signal, okay, and feedback controller, and there is a system DAC and PWM and a robot. Then we'll get the output. We'll get the output, and that output will measured. Output will send to the encoder and the decoders, and according to the desired output, it will compare to the input. Here there is a comparator. It will compare with input. Then you have to fed to the signal to the feedback controllers. Okay, then it will go to the system, and system accordingly it will goes to the output. Again it will goes to the feedback. If it is okay, then it will be right. Otherwise it will control, and control signal will send. Like that, here what happened, this is for a feedback system, it's call it as a closed loop control system. This you can call it as a closed loop control system. So the control systems basically these two types: open loop control systems and closed loop control systems. I hope everyone understand the introductory part of robotics. What are the different types of robots and main components? These the thing I explained in this video.